Hi boys and girls, this is lesson 5.8, subtracting mixed numbers. In this lesson you will learn how to subtract mixed numbers by writing equations, drawing diagrams, and solving number stories. Here we go. Write that down in your notebook as well as the date. Come back. First question, the art students had 3 2/3 gallons of paint for the school play scenery. They used 2 1/3 gallons. How many gallons were left when the students finished painting? Think about how you're going to solve that problem. Do a little work in your notebook. Give it a try. When you think you're ready to check out what I had to say, come on back. Okay, so here are a couple of different methods you could use, and of course there's always others, but here's a couple. So the first one here, use the number line poster. So in the number line poster, you can see that each hole represents a gallon of paint, and if I put my finger on the 3 2/3, then, or 11/3, I guess we can look at it that way. So I'm subtracting, so you know I'm going to be going this way, right? Subtraction would be going this way and addition is this way. So if I'm here on the 11/3, and remember I got to that from 3 2/3 because I know that each of the 3, let me just write this out to the side for you. When I have 3, I know that each of those is worth, each of these is worth 3/3, so 3 of them would be worth 9/3, right? Because 1 is worth 3/3, right? 1 is worth 3/3, so 3 is worth 9/3. So I add that plus the 2/3 in my mixed number, which is how I got to the 11/3 right here. So I'm going to start there, 11/3, and I'm going to count back a third because it says that they used 1/3 and 2 whole, right? So when I get to here, I'm at 7/3. I'm going to count back a whole 1, which is 3/3. 1, 2, 3. And then another whole 1, which is another 3/3. 1, 2, 3. And my answer is going to be 4/3. So I can certainly do it like that, and I know 4/3, which is right now an improper fraction, is 1 1/3. So that's the answer I should have gotten, and that's how I would do it. Another way I could do it, it would be to break the problem into 2 subtraction problems. I'm going to decompose the mixed numbers into sums of whole numbers and fractions, or full gallons of paint and fractions of a gallon of paint. So that means my 3 plus 2/3 and my 2 plus 1/3, that's how I decompose them, right? So there were 3 full gallons of paint to start and 2 were used. 3 minus 2 gives me 1 full gallon left. There was 2/3 of a gallon to start and 1/3 was used. 2/3 minus 1/3 equals 1/3 gallon left. So the class has 1 full gallon and 1/3 of another gallon left, or 1 1/3 gallons. Or with fraction names, 3 wholes and 2/3, take away 2 wholes and 1/3 equals 1 whole and 1/3. So if I'm using it as the unit, I can do it just right here, right? Okay? I could also replace each mixed number with an equivalent fraction greater than 1. So take a look at what's going on down here. I'm converting, which is how I got to 11/3, which is what I showed you up here. And then I'm going to do the same thing with the 2 1/3, so 2 becomes 6/3, plus that 1/3 gives me 7/3, and then I'm going to subtract this 11/3 minus this 7/3 and give me 4/3 gallons, which I know I can convert into 1 1/3. Okay, if that was quick for you, go back and listen again until that makes sense to you, what it is that I said there, because those are 2 or 3 really strong strategies that you could be using. If you get those, feel free to move on. Here's another problem. So Jana bought a 5-pound bag of potatoes to make potato pancakes. Yum. When she finished cooking, she had 1 3/4 pounds of potatoes left. How many pounds of potatoes did she use to make the pancakes? So think about what the problem is that you're going to try and solve there. Do some work in your notebook. Maybe use one of the strategies that we just talked about in the previous problem to help you. And then when you think you're ready to come back and take a look at some strategies we could have used for this one, come on back. Okay, so here you go. I could have done it with fraction circles, and I'm going to do kind of the counting up method here. So I'm going to start by looking at the 1 and 3/4, and I'm going to count up until I get to the 5 full. So I'll add this fourth to make this into a whole one, and then I'll add 1, 2, 3 more, because that would give me 1, 2, 3, 4, 5, and that's what it says she started with, was 5-pound bag. So what am I adding? I'm adding 1, 2, 3, and 1/4. So that's how much was used, right? She used 3 1/4 pounds. Okay? I could break the problem into two subtraction problems, another strategy. So 5 equals 4 plus 1. That 1 is going to be converted into 4/4. And 1 3/4 equals 1 plus 3/4. I can subtract the whole numbers now. 4 minus the 1 equals 3. And I could subtract the fractions, the 4/4, which was one of my whole over here, right, that I converted, minus the 3/4, it's coming from there, equals a 4th. Then I'll put these two pieces back together. 3 plus 1/4 equals 3 1/4 pounds. I could do it with fraction names, 4 wholes and 4/4 minus 1 whole, and 3/4 equals 3 wholes, 4 minus 1, and 1/4, 4/4 minus 3/4 equals 1/4. In either of these, there's like 3 there now, and here comes even another one. I could replace the 5 and the 1 3/4 with equivalent fractions with the denominator of 4, and I would do that because this is the only fraction in my problem that I need to worry about, and it has a 4 on the bottom. So I'm going to convert my 5 into 20/4 because each one of these whole in this 5 are worth 4/4. So 5 of them are worth 20/4. And 1 3/4, I'm going to convert the 1 into 4/4 plus this gives me 7/4, and then do a subtraction problem. 20 minus 7 is 13/4. When I convert that back out, how many 4s go in 13? 3 whole ones with 1/4 left over. So any of those strategies work great as well. So see which of those make the most sense to you, and I think you're going to get to try it on maybe one more problem. Let's see. Here you go. Kevin is a 4th grader and is 4 7/12 feet tall. Kevin's dad is 6 1/12 feet tall. How much taller is Kevin's dad than Kevin? Okay, think that through. Use one of the strategies that you've been shown or one that you like yourself, and give that problem a try. When you've solved it, come back and check your answer on the next page, see if any of our strategies match. All right, so I could think about it like, so Kevin is a 4th grader and is this, and here's my answer, actually, just straight up. There's the answer at the beginning, 1 6/12 or 18/12 feet taller, because that's what we were asking, right? How much taller is he? So I'm trying to find the difference between the two. So here's how I could do it. I could break it into two subtraction problems, like we've talked about each time. However, something to think about. How is using the break apart strategy for this problem different from using it with the previous problem? You should take a look at this and make sure this makes sense to you. But here's the work that I'm going to be showing you, okay? So 6 1/12 is the same as 5 plus 1 plus 1/12, right? So I'm breaking down, I'm decomposing the 6 into 5 plus 1 and the 12th. And if I know this to be true, I also know this to be true. So that is the same as 5 plus 12/12 plus 1/12, right? Because this 1 becomes 12/12. That's what we're showing here. Which means that I can have it equal 5 13/12. When I put these together, I get this. Okay? So then I could subtract the whole numbers from my original problem. 5 minus 4 equals 1. And then I can subtract my fractions. 13/12 minus the 7/12, which is coming from here, right? equals 6/12, so 1 and 6/12 feet taller. I can do that with fraction names, 5 wholes and 13/12 minus 4 wholes and 7/12 equals 1 whole and 6/12. Same. And then I can replace each mixed number with an equivalent fraction. That's another method again. So we're getting into some pretty big numbers here if I do that, but what you can keep in mind is it's a multiplication problem, and you know how to do multiplication, right? So 6 and 1/12 is the same as if I break them down into their pieces. 6 can become 72/12 because 6 times 12 is 72. And then I'm going to add the 1/12 that was left over, so now I have 73/12. 6 and 1/12 is the same as 73/12. And to convert my 4 and 7/12 feet tall, I'm going to do the same kind of concept. I'm breaking this 4 into 48/12 because 4 times 12 is 48. I'm going to add the 7/12 extra to it. 48 plus 7 is 55/12. Okay? So then I'm going to do 73/12, that's the height of Dad, minus 55/12, which is the height of Kevin. When I subtract those, it's 18/12 feet taller. 18/12, that's that improper fraction, I know is the same as 1 and 6/12, because if I take 12/12 away from 18/12, let's just make sure you get that. If I have 18/12 and I take away 12/12, I'm going to have 6/12 left over, right? This 12/12 is 1 whole, and this is the 6/12. So that's why these two 18/12 and 1 and 6/12 are the same. That's how we do that, right? Okay, just one other little quick thing to keep in mind there at the bottom. Take a look at this section in the video. Make sure that makes sense to you. And I think that's the basic lesson for you. Practice problems on Math Journal page 171. Get those going. We're going to talk about them in class, so if you have trouble with any of them, be sure to let me know that. The answers are coming up on the next slide here, so after you do it, come back and check those and fix them in red, or in pen rather, so we'll know. All right, have a great night. There's those answers.